Hi everyone, welcome to my channel. I'm Rishabh, and today we're going to be attempting SAT questions in the topic geometry and trigonometry. All of these are hard questions taken from the SAT question bank, and we're going to be solving 30 questions in 30 minutes since there's a time constraint in SAT, and solving questions faster will always give you more time to revise and your paper efficiently. So in this video, we're going to be seeing how you can use Desmos for specific questions, time-saving tips, and practical methods, pragmatic methods in solving questions. This is definitely going to increase your efficiency, increase your points, and obviously thus increasing your college acceptance. I scored a 1510 on SAT, 750 in the math section and 760 in the reading and writing section. And I lost points in geometry and trigonometry. That's why that's the first video I'm uploading on SAT math. So let's jump right in. Okay, so let's move on to the first question. And it states that in the figure AC is equal to CD, means this is equal to this line, and the measure of angle EBC is 45 degrees, and the measure of angle ACD is 104. What is the value of x degrees? Okay, so the first thing we're going to do is calculate angle BCA. For that, we're going to subtract 104 from 180 degrees to get 76 degrees right here. Next thing we're going to do is calculate angle BFC to get angle EFA. I'm gonna name this point, which is the intersection of angle EB, the intersection of line EB and AC as point F. So we're gonna be calculating BFC, this angle. We are gonna use, since a triangle, sum of all angles in a triangle is 180 degrees. We're gonna add 45 and 76, subtract it from 180 to get 59 degrees. So 180 minus 76 plus 45 degrees, that's equal to 59 degrees. Since this angle is going to be equal to angle EFA due to the opposite angle theorem, uh, angle EFA is also going to be equal to 59 degrees. Angle CAD and CDA are going to be equal since this is an isosceles triangle. And so 180 minus 104 by 2, that's 38 degrees. So this is the value of angle CAD. Yeah, and now this triangle right here and triangle EFEA, we have got x degrees, 59 degrees, and 38 degrees. So the sum of all angles is going to be 180, and therefore x is going to be 83 degrees. Moving on. Okay. Okay, we are going to be using the exterior angle theorem here. First, we need to calculate is this angle uh, right here as the first step. Then second step, we are going to use the exterior angle theorem. So in the first step, we calculate this angle to be 74 degrees. And our next step is to use the exterior angle theorem, which basically states that if you have a triangle like such, this exterior angle should be equal to the opposite of the interior angles sum. So x degrees should be equal to y degrees plus z degrees. We're going to use this here to get x is equal to 97 degrees. Moving on, okay, it's quite a long question. In the figure shown, points QRS and T line on line segment PV, RU intersects line segment SX. Measure of QX is 48. Measure of SXQ is 86. Measure of SW is 85. VTU is 162. And what is the measure of TUR? Okay, I'm going to label TUR as 85 degrees. The first thing I'm going to do is calculate RTU, which is going to be 180 minus 162. That's 18 degrees. We are basically going to calculate angle RTU and angle TRU, and then add these both together and subtract them from 180 to get x degrees. So to calculate RTU, we are going to get our SW, which is going to be 180 minus 48 plus 86 degrees. This is going to be 180 minus, wait, let me just write it here. Yeah. So 180 minus 48 plus 86, that's going to be equal to 180 minus 130. 134. That's going to be equal to 46 degrees. So this is going to be equal to 46 degrees. Now we can calculate angle RWS. We're going to subtract 85 from 180 to get 95 degrees. That's RWS. We're going to add these both angles together, subtract them from 180 to get SRW, which is going to be equal to 39 degrees. So we have got angle TRU and we have got angle RTU. We're going to add these together, subtract them from 180 and get X degrees, which is 123. And square A has side lengths that are 166 times the side lengths of square B. Area of square is K times the area of square B. What is the value of K? So the sides of B is, let's say, X, and therefore the sides of square A should be 166x, and these two areas are going to be equal except area of square B is going to be K times the area of square A. Equating these and equating this equation, dividing both sides by x square right here, we get K is equal to 166 square, which is going to be 2756. Okay, moving forward to the next question. And a right square prism has a height of 14 units. The volume of this prism is 2016 cubic units. What is the length in units of an edge of the base? Okay, so this is how an right square prism looks like. They are basically squares on, or you can say, a 3D rectangle. So a rectangular prism would have its different length, width, and height, but a square prism has the same length and width, basically sides, and the height is different. So this is a square prism. The height is 14. The length of the sides are x, and we're basically set to find the edge of the base, which is basically a side of the square. So x squared times 14, this is the volume, is equal to 2016, and we'll calculate this to get x equals root 144 and x is equal to plus minus 12, or x is equal to 12 units. Moving forward, okay. In the figure above, NQ and NR intersect at some point. NP is equal to QP, MP is equal to PR. What is the measure in degrees of angle QMR? Disregard. Okay. So, okay, this is basically, I'm taking this triangle right here and drawing it enlarged like this. So we need to find x degrees. This is an isosceles triangle. We are going to use the exterior angle theorem right here. So 60 degrees should be equal to the sum of this angle and this angle. And since these two are the same, we're going to label it as 2x degrees, and therefore x is 30 degrees. Okay, a circle in the xy plane has its center at negative 1, comma 1. Line T is tangent to the circle at 5, comma negative 4. Which of the following points also lie on T? Okay, so this is a relatively big question. So we are going to be following these four steps. The first thing I'm going to do is find the slope of the normal, which is the line joining the center of the circle with this point, which lies on the circle as well as the tangent. The next thing I'm going to do is calculate the perpendicular slope to this slope, which is going to be the slope of the tangent. And then we're going to input all these values into the line equation. We're going to input the slope of the tangent and the points 5, comma negative 4, since it lies on the tangent as well. And then we're going to check all of these options. We're going to input the equation into Desmos. We're going to input all of these points on Desmos and check which one of them lies on the line. So let's calculate the slope first. We input all the points accordingly to the slope formula. We get the slope of the normal to be negative 5 upon 6. We get the perpendicular to the slope by dividing it by negative 1. We get 6 by 5. This is going to be a slope of tangent. And after that, we input all of these values into the line equation and we get this equation. Now we basically have to input values. You can either graph this in Desmos and check all of these values, or you can also input these values into the equation itself, and these values will satisfy, and we'll get answer C. Okay, moving forward. So a cube has an edge length of 68, solid sphere with radius 34, such that sphere touches the center of each face of the cube. So this is a cube, and basically the sphere is going to be such like this. Uh, Imagine it to be 3D. I can draw 3D as well. So the length of the sides are 68. So just label it here. The volume is going to be 68 cube, and the volume of a solid sphere is 4 by 3 pi r cube. You're given a formula sheet during the SAT, so you can always consult that. Although not all formulas are given, such as arc length or surface area of like rectangle or even square. I don't think that's provided to you. But all of these are you can relatively easy to create the formulas on your own, but it's always good to memorize the formulas. So the volume of a solid sphere is 4 by 3 pi r cube. You get this to get this number. You subtract uh, this volume of solid sphere from the volume of cube to get the remaining area. Since we are supposed to find the space in cube not taken by the sphere, so we have to find the remaining volume, which is going to be this number. You can use Desmos for this entire thing. Okay. In triangle ABC, this is triangle ABC. The measure of angle B is 90 degrees. BD is an altitude of the triangle, which is basically a perpendicular line to the hypotenuse. The length of AB is 15. The length of AC is 23 greater than length of AB. What is the value of BC by BD? So 23 greater than 15 is basically 38. And I'm going to split this into two triangles like such. Since these two triangles are going to be similar to each other, the proportion of the sides of these lengths of these triangles are going to be equal. Solving this, we get 38 by 15. Since your BC by BD, this angle, this side upon this side is going to be equal to this side upon this side. We are basically the ratio of the corresponding sides of two similar triangles should be equal. That is your similar triangles side property, whatever you want to call it. Okay, so move on to the next questions. The solution to this is going to be a bit complicated. If you find a better solution, a more efficient and straightforward solution, you're welcome to comment. So basically, you need to find x degrees, and the angle TSV, VST is 29, and angle RVS is 41 degrees. We need to find x. So I'm going to label angle TUR and angle TRU as 5 degrees. Both of these are going to be equal. This is an isosceles triangle. So basically, our first equation is that x plus 2y is equal to 180. And in the next, basically, we are going to use 180 minus 41 plus y now. Which angle is this referring to? This is referring to this angle right here. Technically, it refers to this, but these two angles are going to be same due to the opposite angle theorem. Angle 1 is equal to angle 2. So we are going to add this with 29 degrees plus 2y. This is right here 29. So this angle is going to be 180 minus 41 plus y degrees. This angle is 29, and this angle is going to be the sum of uh, angle TUR and angle TRU, which is 2y. This right here is the exterior angle theorem. So we are going to use that to get this equation. When we solve this equation, we get y is equal to 12 degrees. We substitute this into the first equation to get x is equal to 156. Although this is straightforward, there aren't very huge steps or are very complicated. The notation can be a bit difficult to understand. So I recommend you go through this again. Yeah. Yeah, so I recommend you to do it again since this is an interesting question and it has a likelihood of coming into the SAT. Okay, so next question we are given two triangles WZXY intersect point Q, YQ is 63. I've drawn the figures here. I'm going to read the entire question. And we need to find the length of YZ. Okay, these two triangles are going to be similar to each other. So WQ upon WX should be equal to WQ upon Wait, no, it's not wx. This is wx. Should be equal to yq upon yz. Solving this, we get yz is equal to 52. These triangles are going to be similar, and we are using the same property we used in one or two questions back. Okay, so the circle above has a center of the arc length 5 pi, ADC is 5 pi, and x is equal to 100 degrees. What is the length of arc ABC? This arc right here, we need to find length of this. First thing you're going to do is convert 100 to radians. You're going to multiply it by pi by 180 to get 5 pi by 9. The length of an arc follows the formula S equals R theta. We're going to input the values theta as 5 pi by 9, S as 5 pi, and we'll get R is equal to 9 units. R here is the radius. So now we can calculate angle ABC, length ABC with the same formula S equals R theta. Theta is now going to be 2 pi minus 5 pi by 9, since this angle right here is 360 degrees, which is also 2 pi, since pi is 180 degrees. Calculating this, we get 13 pi. We input all the values, radius 9, angle 2 pi by minus 5 pi by 9, and we get 13 pi, which is option B. Next question, okay, this is a theoretical question. So in triangle ABC and DEF, the angles BE each are measured 27, CF each are 41. So, okay, this is your triangles, and we need to determine which additional piece of information is sufficient to prove whether triangle ABC is congruent to triangle DEF. Basically, congruency means that these two angles are absolutely equal to each other. There's absolutely no difference. They are the same length of sides, same angles, same properties. These are basically the two same angles, clones of each other. So there are four congruency criterias that two triangles need to follow to be counted as congruent triangles. There is triple S, SAS, ASA, and double AS. And I have written the names of these here. You can check these out, and you can also see some video. Basically, these two triangles are going to follow the fourth criteria, which is AAS, or angle side. So this angle and this side and this angle are going to be equal to each other. So the sides of length BC and EF. So angle, side, angle, angle, side, angle. This is a property. This is the criteria, congruency criteria that we follow. And therefore, this is the only additional piece of information required. Moving forward to the next question, sine B is equal to 5 by 13. ABC is a right triangle. Length of side BC is equal to what? So sine B is AC by uh, AB, which is 5 by 13 as given. Therefore, x by 26 is equal to 5 by 13. X is equal to 10. Now we're going to use the Pythagorean theorem. AC square plus BC square is equal to AB square. Solving this, we get 24. This is also a famous Pythagorean triplet. Phi, which This is also a Pythagorean triplet where the hypotenuse is 13, and these two sides can be 5 or 12, or 12 or 5. So in triangles LMN, RST, okay, we're given this information. I have written them here. So this is 10, this is 30, and these triangles are 60 and 60. So what additional piece of information is sufficient to prove that these two triangles are similar to each other? We're not proving congruency here, we're proving similarity. Okay. So for that we will 70, 50, 70, 50, 70, 70. Angle D should be the correct answer. For this to be 70, this will become 50. Therefore, this will also become 50, and this will also become 70. All the angles will become equal, and therefore these two triangles will become similar to each other. So answer D is correct. Option D is correct. Okay, so we are given an equation of a circle and we need to find the length of the radius. Okay, so basically, since we are given an equation straight away, so you can simply plot it into the Desmos. You will find a figure like this, and these 2 points right here on the y-axis, this is not going to be the diameter. These are just 2 points. So don't take the difference, although Desmos will give you a different point on the left, these 2 points, and you can find the difference of these 2 points, the y difference of these 2 points, which will be equal to 20. That's your diameter, and half of it's the radius 10. Okay, moving forward to the next question. We are given a right angle triangle ABC. What is the value of tan A? Okay, so tan, I think it's yeah, it's a right angle triangle. This is 30, this is 90, this is 30. Therefore, tan A should be tan 60, which is equal to root 3. Option C is correct. Okay, we're given another equation of a circle. Point AB lies on the circle is the following is a possible value for A. Simply plot this into Desmos, you will get this as a circle. And since this point, we're talking about the x-axis, we are talking about the x coordinate of the point. Basically, you can plot, I'm going to use a different color. You can basically plot in x is equal to minus 16, x is equal to minus 14, x is equal to 11, x is equal to 19. And finally, x is equal to minus 14 will intercept the circle like this. Therefore, option B is correct. Moving forward, another circle is given. What are the coordinates of the center of the circle? Okay, another one. Simply plot this into Desmos itself. You will be able to find the endpoints of the diameter, and then you can find the midpoint of the diameter to get the y coordinates of the center. Since the x coordinates are going to be the same, which is going to be minus 8, and that is option B. Another easy question, what is the value of sine x? Sine x is going to be 16 upon 23. Next question, yeah. Another circle given, diameters are provided. An equation of this circle is this. R is a positive constant. What is the value of R? R is the radius of the circle. So we are going to be finding the distance between these 2 points. These are the endpoints. So we're going to be finding the distance between them, which is going to be 10. This is the length of the diameter. It's also been said these are the diameters endpoints. And half of this is going to be the length of R, which is 5. So your R square should be equal to 25. But we're only talking about the value of R, so R should be equal to 5. Yeah, 5 is correct answer. Okay, we are given a circle and point O is the center of the circle above. Measure of angle OAB is 30 degrees. Length of OC is 18. What is the length of RAB? So I have enlarged the circle and drawn it here. So your OC, which is the radius, is 18. Your angle OAB is 30, and yeah, we need to find and the length of arc AB. So since this is 30 and these two lines are going to be equal in length, these two are the radius of course. So angle ABO is also going to be 30. Subtract adding them together, subtracting them from 180, we're going to get 120 degrees. This is angle OAB. We are going to convert this into radians to get 2 pi by 3, and we're going to multiply it by the radius to get 12 pi as the length of RAB. Okay, so graphic designer is creating a logo for a company. The logo is shown. Trapezoid consists of three congruent equilateral triangles. Perimeter of logo is 20 centimeters. Combined area of shaded region is. So this is the logo. There are five sides. The total perimeter is 20. So the length of one side is 4 centimeter. Now we're going to draw one triangle. I'm going to take this one triangle right here. We are going to draw perpendicular, and since it's an equilateral triangle, the angle is going to be 60 degrees. Tan 60 should be equal to h by 2. Since total of this is 4, so half of this length should be 2. So h by 2, h is equal to 2 by root 3, 2 into root 3. We are going to plug this information into the area of the triangle. 1 by 2 times 4 times 2 root 3, half into base into height. We get area as 4 root 3. Now this is the area of one of these triangles. For the total area, we need to multiply it by 2, and we get 8 root 3 as the answer, or option C. So get 8 root 3 as the answer or option C. Okay. Circle A has this equation. Circle B has same center. Radius is twice. So what is the value of K? Okay, so what is the value of R square or RB square? Yeah. So the radius is going to be 2 of circle A, since this is 4. This is equal to R square. R should be equal to 2. And circle B's radius is twice, so 4, and K should be equal to R square, so 4 square is 16. Answer is 16. Diameter of the circle in the xy plane with equation this. So radius is going to be the root 4, and diameter is going to be twice the radius 8. Option B is correct. Perimeter of an equilateral triangle is 624. Height of this triangle is k root 3. K is a constant. What is the value of k? So the perimeter of any equilateral triangle is 3s. So the length of one side is going to be 208. And the length of half of the side is going to be 104. We are going to use trigonometry. Tan 60 is equal to k root 3 by 208 by k root 3 by 104, dividing by root 3, and we get k is equal to 104. Okay, so we're given a cube. We need to find the surface area. So a cube has, okay, so the volume of this cube is this. We take the cube root to get 78 to get the length of side of each square forming the cube. So now 6 squares form a cube. So the area of all of these squares is going to be 6x square, 6s square. And this is equal to the surface area. So 6s square is 6 times 78 square, which is 36504 as your answer. So a right circular cone has a height of 22 centimeters and a base with diameter 6 centimeter. The volume of this cone is n pi centimeter cube. What is the value of n? So volume of cone is pi r square h by 3. The height is 22 and r is 3 centimeter. So input the values, solve, and we get 66 pi. So n is equal to 66. And last question. So ABC, angle B is a right angle. Side of AB is 10 root 37. Length of side BC is 24 root 37. What is the length of side AC? Plotting all the information into the diagram, we're going to use Pythagorean theorem, and we get answer as 26 root 37, which is option B. So that's it. We are done for today. 30 questions done in 30 minutes. So I'm going to look forward to you in the next video. We're going to do more questions in every single question 1 minute, X questions in X minutes. So let's meet up in the next video. See you soon. Bye.